Here's page 3 of the regular and honors review packet for Unit 3 at West Springfield High School. So let's get started. It says find the value, now we're on skill 8 by the way, find the value of x that makes the lines parallel. Well, before we even move on, remember when we're trying to prove that lines are parallel, if we have to justify, we're using the converse of our postulates and theorems. Let me remind you why that's the case. I'm going to write up here. We know that if lines are parallel, then rules work. And what I mean by that is alternate exterior angles are congruent. Same side interior angles are supplementary. So if lines are parallel, then rules work. Well, take a look. This is my P. This is my Q. If I want the converse, I need to rewrite it. So here's my converse. And I want to underline that so you really can see that's what it is. The converse would say the other order. If the rules are working, then lines are parallel. We'll take a look. Rules work is Q, then lines are parallel is P. So notice the order switched. So the converse lets us prove that lines are parallel. So let's look at A. It says find the value of x that makes them parallel and name which theorem or postulate is used to prove it. Well, if we want J and K to be parallel, then we need these corresponding angles to be congruent. So let's do that. Whew, okay, I'm going to subtract my 7 onto that side. I'm going to subtract that x onto this side. And that's going to give me a value of x equals 9. But we don't just want the value of x. Okay, now remember, if x is 9, let's plug things in really quick. That's going to give me a value of 52 degrees for this angle. And it's going to give me a value of, perfect, 52 degrees for that angle. Well, now that those angles are congruent, we can say that line J is parallel to K because of the converse of the corresponding angles postulate. That's A. And I'm going to highlight that. I really want that to stand out. Make sure you use the word converse of the corresponding angles postulate and x equals 9. Let's do B. We want these lines to be parallel, and in order to make sure they're parallel, these same side interior angles need to be supplementary. So this plus this equals 180. So let's do that. If I combine my like terms, I'm going to get 11x plus 4 equals 180. Okay, well that's going to give me 11x equals 176. And 176 divided by 11 is 16. So now I have my value of x. If I actually plug it back in, 16 times 4 is 64. 64 plus 10 is 74. 7 times 16 is 112. 112 minus 6 is 106. Well, that's perfect. Those add up to 180 like they were supposed to. So now we can say that these lines are going to be parallel because of the converse of the same side interior angles theorem. Okay, remember that converse because we're proving they're parallel. C, okay, if we want these lines to be parallel, then these alternate interior angles are going to need to be congruent. So let's figure out what value of x makes them congruent. Okay, I'm going to subtract 21x onto this side. I'm going to add 5 to this side. If I divide both sides by 2, I'm going to get that x equals 5. But now I need to justify response. Well, remember, if this is 5, then I can plug in 5 here. 5 times 21 is 105, plus 5 is 110. Okay, 23 times 5 is 115. 115 minus 5 is 110. Good, my angles are congruent. So my lines are parallel because of the converse of the alternate interior angles theorem. Fantastic. Okay, D. Oh, this is an angle relationship that we have a name for. Let's take a look. We know that this, and this need to be congruent. We know that this, and this need to be congruent. Well, these two, this has a dot, this has a star. That means if these are going to be parallel, these two things need to be supplementary. They need to add up to 180. So let's do that. That's going to give us 5x plus 120 equals 180. That gives me that 5x equals 60. So x equals 12. Let's plug that back in. 12 times 3 is 36. 36 plus 65 is 101. Let's check down here. 2 times 12 is 24. 24 plus 55 is 79. Oh, good. They add up to 180. That's what we need. Here's the thing, though. We don't really have a name for a postular theorem for this angle relationship where one's on the outside, one's on the inside, but they're on different sides of the transversal. So I'm not going to leave a name, but what is important is we're using converses of things to prove this. So we'll leave it like that for now, and we can talk about that more in class. But that doesn't have one postular theorem. It actually needs a couple of them to prove it. So there's not just one. Let's go down here to 7. It says, are lines P and Q parallel? Indicate why or why not by giving the converse of the appropriate postulate or theorem. Okay, so let's take a look. Are P and Q parallel? Well, in this relationship, these should be the same. And then the 4 without dots should be the same. So I have a dot and a not dot. That means they should be supplementary. And yes, indeed, 130 plus 50 is supplementary. So we're going to say, yes, they're parallel. And the reason is because the converse of the same side interior angles theorem. Okay, B. If these lines are parallel, these 4 angles should be congruent. Well, 68 and 70 definitely aren't the same number. They're not congruent, so they are not parallel. Okay, C. Remember, these 4 things here should be congruent, or the 4 without dots should be congruent. They both don't have dots. Therefore, since they both don't, that means they're the same. So since these are the same, we're good. So yes, they're parallel because of the converse of the alternate interior angles theorem. Okay. D. Well, these two are supposed to add up to 180, and they do, but wait a minute. Even if these add up to 180, that doesn't tell us anything about this line up here. This line P, and I'm going to use a different color, could go off at a really weird angle like that, right? And these would still add up to 180. So that we don't have a converse of the linear pair postular. We only have a converse of the ones that have 1 in each intersection. So we're going to put not parallel. Right, because we only have information in 1 intersection. This line could do crazy things and it wouldn't impact what's going on down here at all. Okay, let's look at E. We know that this, and this should be the same. This has X, this has X. Even though we don't know the value of X, we know that these are going to be congruent because whatever value this is, let's say we put in 80, this will be 80 as well. So those two have the same value, so we can say yes, they're parallel, because our alternate exterior angles are congruent. So that's the alternate exterior angles theorem. And I forgot a really important word, and that's the word converse. So we can say that these lines are parallel because, so it's a converse because the alternate exterior angles are the same. Okay, last one we have F. Notice once again we have 2 angles only in 1 intersection, so we know nothing about what's happening with P. P could be off at a really wonky angle like this. They might not even look like they're parallel. Right? So we don't know that they're parallel, so not parallel. Great, so that's the answers for page number 3. Go ahead and find video number 4. You're almost done.